Screen share, desktop one. Okay. There we go. All right. A Getty is what puts this login on. Okay. Now, when you boot your machine and you see all that stuff scroll by, that's called the console. So the console is separate and distinct from the Getty. On your Linux boxes, your default console is TTY F1. You know, you can control F1, F2, F3. Well, I'll show you what the problem is when you have a Getty on the same console. What happens is that when you do something with your, let's see, how am I going to do this? Oh, I guess I could unplug it. This, that'll work. Now, if I unplug this, this is a cable. It's a USB cable. Unplugging it, you don't see any changes. And I plug it back in. And then what's happening is some changes happened. Let me log in over here. That is all the stuff for your machine booting. So when you say console, this is what comes through. When you say Getty, you get a login. So when you turn on a Getty and the console onto the same port, can you imagine what happens? You get things interlaced into what you're working on. It can be quite irritating, but you can work around it, okay? All right, so if I do demessage here, now let's just say, let me do this. I'll do it for X in $ sequence 1 to 100 do sleep 1 second, and I'll simply just say echo minus n star. Done. So what it's going to do is simply display stars for 100 times. So now if I go through and see if it's going to behave here for me. And then technically this should display the console, which I'll show you another way. Okay. Notice it's doing its thing. Rebooting. My console messages are going to my serial port. Now, the reason I'm kind of driving this home is back in the day, the serial console used to be a printer. And this printer would go bzz, 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 for every single one of those messages that you saw. Used a lot of paper, but this was in the old days when screens weren't working. But you can see it's still working but I can't do anything. In other words, I can't stop the boot process with the keyboard. This is the console. It's display only. And you can, on high-end servers, set up a monitor and say, that's going to be my console. And all my messages go to the console. Now, I used to do that in the computer room at Foster Farms. So the boss would come into the computer room and see all this activity going on when it was just a bunch of stupid log files. He had no idea what he was looking at. He could care less. But the machines were busy. That's what made him happy. Play the game, right? So now once this machine reboots, I'm back at my login prompt here. As you can see, I'm logging back in and it's telling you these errors. And I'm not sure what this GPIO stuff is, but it all started happening when I enabled the serial port. When I installed the first version of the operating system, this little thing, this screen went this way. See? So you had to type in, I guess I better figure out how to straighten out the screen. So when you get weird hardware, you get to play with, yeah.
GPIO is the Raspberry Pi proprietary data.
Yes, that's the general purpose IO is what that stands for. But this isn't a Raspberry Pi. I'm not sure what its guts are. It's made by, I don't even remember who, but it's basically an 8 gig notebook, 4-core, 8 gig. It does what I need it to do. So I'm logged in and I still have my Getty now. Okay, that's a quick demo of the serial stuff. Now I'm going to do a quick demo of this. Okay. XRDP. How many have done remote control on their Windows machines? All right. How many know that you can do remote control on your Windows machine? How many didn't know you can do remote control on it? You can. And the protocol, it's called RDP, Remote Desktop Protocol. And it's a ripoff of some open source tools that Microsoft embraced and extended many years ago. And Microsoft has open sourced it. Amazing. Now what's happening is that RDP is replacing a lot of the remote desktop protocols that were alive in Linux. There was VNC, there's 85 flavors of VNC, all different protocols, VNC 5, VNC 6, and they all have different strengths and weaknesses. Then you have X Windows over blah, 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 or XRMDP. But RDP is simple, fast, and it mostly works. So on your Windows machine, you can remote control another Windows machine by using the Microsoft Terminal Services Client. I never can find it in the menu, so I just use Microsoft Terminal Services Client from the command line, and that gives me the ability to remote control another machine if the permissions have been set. In other words, if you don't say remote control, they're not going to be able to remote control it. Okay? The tool, one of many client pieces, this is the server, this is the client. One of the many client pieces on Linux is called rdesktop, as a remote desktop protocol. Okay. Now I'm going to demo this, show you how it works, and then I will show you how to make it work, not today, but how to make it work on the Jeremy box. Think about that for a second. You're on a Jeremy box. You're on SSH. You want a GUI? I can show you how to do it. Okay. If you're on your own Linux box, I can show you how to do it. Okay. So basically, what you end up doing is, let me log in to the box this way. I guess I have to do it this way. Now I'm cheating. They say cheaters never prosper, right? Wireless. Wireless. I cannot access this by machine name .yosemite.edu. Doesn't validate. Nor can I access it through my yosemite.edu. Nor can I access it through yosemite.cce.ca.edu or US. Those are the domain names that are part of Microsoft Active Directory. How do you bypass it all? Use the IP address. Bypassing all of that stuff. Now, here's what's going to happen with you on student Wi-Fi. If you are on one notebook connected to the wireless, and you're on another notebook connected to the wireless, it will probably work. If you're on a notebook and then you're on one of these machines that are wired, it will not. The reason mine works because I'm using my, when I did the Wi-Fi connection, I did not use student Wi-Fi. I'm using my actual instructor login credentials, which are put into a bigger security bucket, or in other words, more open-ended security, but they don't have that dialed down very tight. If they did, I wouldn't be able to do this, okay? So I'm going to log in. There it is. Now, how do you check to see if RDP is running? System services, whatever. What port runs on HTTP? Fire away. 80, right. What about SSH? Oh, so close. 22. 23 is Telnet. These are on your CompTIA tests, all these ports. The port for RDP, both on Windows and on Linux, is 3389. Now, what's one of the first tools that we install when we get a Linux box running that I happen to use? Nmap. What does Nmap do? It tells you what ports are open. Okay. Not necessarily available, but it shows you what ports are open. So if I do nmap localhost, notice I have 3389, which means I've got the remote desktop server running on my little 8 gig thingy here. Here's how you connect to it. There's more than one way to do it, but this is the way I like to do it because then it's only going through port 22. It's a little slow, but it works. So I've logged in as me. Ta-da! Now I'm ready to use my client, our desktop. If I can spell it right. Then I tell it what user I want and localhost. I now have a full-on GUI. 3389 is being tunneled through port 22 automatically. I'll show you how to configure that later. and will probably ask me a bunch of questions. Now, system policy prevents Wi-Fi scans. I have no idea what that means, but I put in my password for that. And then it says system policy prevents Wi-Fi scans. And I do it for that one. Authentication is required to create a color profile. And it's asking for it twice. Why? I don't know. 3 times. Let's see how many times it takes. I know this works. I did it earlier today. It's just kind of irritating to type this in so many times. I'm just putting in my password. Now I've got another question. Maybe I'm typing my password wrong. This is because I haven't got it all configured correctly. Okay. All I did was turn this on and use this desktop. Log in. Boom. I haven't tweaked it at all. Rdesktop and xrdp will allow you to put video from this machine through that. It will also allow you to take audio from this machine to this one. So you can actually pipe music from a server that's in another room to the speakers on your local host. Not that you'd want to do that, but you can do that. Okay. That's part of the things you can do. So now if I just open a terminal here, let's open that one. So I now have a full-on GUI running through SSH of this little guy. Okay. That's what this brings to the table. Okay. That's this part right here. So there's a lot of pieces in this puzzle that have got different pieces of history to it. But at the moment, this seems to be the direction the market's going, because now I can use Microsoft terminal services from either a Windows or Linux client to manage either a Linux or Windows server. You can see the advantages to that. Okay. Rather than having one protocol for Windows and another protocol for Linux, which is the way things used to be, or kind of can still be if you want it to be that way. Okay. So I'll bring up Brave here. So you can see it's not too shabby, but it's not terribly fast either. But I'm through wireless, so it's going to stutter a little, but it works fine. So now everything's here, and I'm getting errors about xclip. So watch what happens here. I'm inside my GUI, and all the way back to my serial port. It's disconnected, and eventually I'll get a message. Maybe. And we'll go back, and it shows you the reboot. Okay. Now, did I confuse everybody with all that stuff? Probably. Now, we are going to do all of this over again, and I will show you also how to connect the serial port to your virtual machine. She'll be able to do the same type of practice on your virtual machine. Okay. Now, let's talk about the tool that you're going to love. Okay. Now, this can be, you need to be on a Linux box for this. So log into Tux in the machine in front of you using the Jeremy 231 password. Okay. And I'm going to close this. All right. So once you're logged in to the Jeremy box in front of you, open another terminal window and log into the Jeremy server with your login. So do SSH, whatever your first name is, and your 6-digit at jmkll.org, whatever your password is, okay? Or I'm gonna alias. So I'm logged in twice now. I'm logged in locally in front of me and at the box in the computer room. We're only using SSH. This will also work on any other box that's got SSH open anywhere on the planet. This is a great way to move data files back and forth. I'm going to show you how this all works. Okay, you're working in the lab over here on the Jeremy box in the back room, and you have to, and your SSH, and all of a sudden you spent, 14 hours working on your function file, okay? And let's just say the function file is multiple pages long. It's really long, but you want it on your local machine. How do we do that? What makes it easy? Well, I want to get it, but yet I have data on my local machine. I want to get on the target machine or the faraway machine. I want to move data back and forth. There's literally hundreds of options in this space. I'm going to show you this sshfs because it works kind of with Windows. Not very well. It gets better, but it's still kind of lumpy. If you use the Moab Xterm or the Mabe, whatever it is, Xterm, all that works, it works flawlessly. So here's what you do. This is called a mount point. This is something that's mentioned in the test out. We're going to create a new directory on our Jeremy box in front of us. So step one, let's make it easy. Let's say make directory and call it jmkll. Okay. There's nothing in it. So I'm making a directory locally, and then I'm going to connect locally to my home directory. So I'll be able to do things in that directory that manipulates things over there. Now, the nice thing about this is, like when I'm at home, I use sshfs a lot because I don't have the fastest bandwidth. It's really, really steady. I get zero chatter, but it's just not that fast, okay? So here's how sshfs works. sshfs, then you give it your login name, and then you give it the local name. And I don't think you need the slash at the end of that second one. So can you kind of see what we're doing here? We're using something similar to SSH, where we log in with username and so on and so forth, okay? But what I'm doing in specific is I'm saying SSH file share, go to that server, colon is important because it defaults to 22. You can put your SSH server on 22.22, but then I would say colon 22.22. Okay. /home/DKP. I don't want that. I want /tux. You are going to use your own. Okay. So on your machine, it's going to look like this. whatever your name, okay, home, and whatever that's going to be, okay. And then locally, we'll call it tux, okay. Let me widen this out a little bit. So that's completely bogus because basically first name digits at the Jeremy box, home, first name digits, to your local machine in front of you, logged in as tux, to home tux, and the directory you just created. Does that make sense? Okay. So I'm going to change it to what I've got. So if you use tux, you won't know the password and it won't let you in. So now it remembered my password. It knows I'm there. Do df. Look it there. Home tux on the remote server is now in my JMKLL box. Okay. So change directory. Everything I do here is going to show up on my server. This is just like a file share in Windows where you share a folder and connect it to another machine. It's the same process. It's just we're using SSH, which this is great for small stuff. I would not want to use, in other words, if I said, okay, we're going to set up the Jeremy box and you're all going to get an sshfs file share to do all your own stuff, that is not the right tool for the job because it would become dog slow. There's a lot of overhead with this. There are faster protocols in FS for one, and CIFS in Windows.
Second one is local, so we change this to tux, this machine is and just leave the JMK. I was literally like that in this right now, so I can segment it in my mind.
So let's make sure everybody gets caught up here. So we're doing SSHFS, telling it, let's mount our home directory to our local machine. That's all we're doing. So now we have stuff to do. Okay. Now you're going to have a bunch of different things in your home directory and in your bin directory. What I want to show you now as we move into this is this tool called shellcheck. This is where your assignment's going to come in for the 21st. I'm going to give you some source code that does something. And you're going to comment it and explain to me what it does. Okay. And you're also going to fix the little bugs in it by using shellcheck. It's an online tool if you are so inclined to use it, but it also installs locally. What's nice about this particular tool is it supports all kinds of flavors. It does bash and Z shell and corn shell and you name it, it probably handles it. But this is an open source tool that's been developed over many years. And you can actually use this online. And they have different editor plugins for it. So you can choose which editor you want. You can make it all cloud play if you want. Okay. But saving you some headaches, it's installed on the machines in front of you and on the Jeremy server. So if you type in shell check on, I think you have a hello world. Guess what? It's telling you something. It says, first of all, let's just run it, show you what it does. That's it. It says, hello world. Hello, Dale. How are you? Here's your fortune of the day, blah, 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 blah. Okay. So let's cat it so you can see it. Doesn't do much. There's your fortune. Now, let's do it this way. S, short. Look at a short fortune. So now when I run hello world, short fortune. Okay, there we go. So now I do shell check. Hello world. And it gives you all the wonderful reasons why I have an error there. This is pretty darned exhaustive. The reason we have problems with C and C++ and memory overflows and all that good stuff is because programmers forget things and they forget to close off memory. They forget to deallocate memory. Bash is even worse. There are so many things that you can leave a hole in and you don't even know it because it works. So it says read without -R will mangle backs. Ow! I don't think that's what they mean, right? They mean maybe backslashes. So you can click here and say open link and then bring it back over here and it says, or. Now this IFS is special. I will teach you about that later. Okay. And it's explaining why it says leading to the USB strip from the view, but it's talking about safety. Okay. Will mangle backslashes. Just play with it. Let's see what mangled backslashes look like. Look what I typed in versus what it printed. I typed in that, and this is what it printed. Okay. That worked. Let's try that again. That one worked. So it looks like read is not letting me embed escape sequences, which is good. So let's do this. DA. Control G, that's a beep. I don't have sound set up, so you can't hear it, but you can really annoy people by putting lots of beeps in your scripts if you know their terminal is going to display a beep, you know. So even though I typed in the backslash, this is why I say it's mangling it. So let's fix it. How do we fix it? We just use -R. Now we can run it again, and I'll use the same one. My backslash is now there. Okay, so shell check is giving you a clue on what to do to make your stuff more robust. Now, what do we got? Where are we going? On the Jeremy box. In the home logs directory. Your assignment. Mission Impossible theme song. This is a script. Notes is a script that is not in your home directory. It is not installed on the machine. I found it on GitHub and I'm using it every day. I find it quite useful. So you have to make a copy of that into your bin directory and you get to play with it. You're going to edit it, add comments, and use shellcheck to fix all the bugs. And you're going to tell me what bug you fixed. Okay. So be sure to copy first. I'm going to repeat that. Be sure to copy first. Okay. So I'm going to do that. Copy notes to ~/bin. So I'm in home logs. So I did cd/home/logs. And then I said copy notes to ~, which is my home directory. Yours would be different. Bin, I want it in the bin directory. And it will call it notes. I hit enter. Copied, change directory to my bin directory. And we go to the bottom of the screen. I made it too big. There it is. It's executable and everything. Now, what does it do? That's what you get to find out. I'm going to play with this and see what it does. Okay. It does a couple different things. Basically, it is nothing more than a simple way to take quick notes. And you'll learn how to use it. And what's nice about this, it's only 500 lines long. So you'll be able to understand it. And it's fairly well commented. So it's not ridiculously complex. They use some good techniques and they also skirted some techniques. They cheated, shall we say. All right. Now, let me go over here. Let me do that. Oh, boy. I doubt we'll get into this, but this is the kind of thing you can do with this. So I'm going to add this to my notes right here. Notes, and I'm going to make sure it says home tux bin. So it's my version. This is how it's installed. I'll have to make that smaller. Sorry for the people in the back. What is this doing? Curl is like wget. Goes to a website, pulls off a file. That's what it's doing. And then it says, latest release install.sh. You don't get install.sh. It comes down when you say sudo bash. What ends up happening is that install.sh runs through sudo, through bash, creates the script and sets the permissions and exits. Can you see this is a lovely exploit? This could be so dangerous. So don't do this unless you know where it's coming from. Because it was on GitHub, I looked at the source code first, then I did this, because this is such an easy way to install a backdoor. And there's a way to create what they call self-extracting bash executables. So you create your bash and you kind of crunch it up and somebody just clicks on it and it recreates itself in all its glory and hides itself on the file system. Yeah, it's happening. Okay. So this is how it gets installed. Notice that's the cheat. They're creating configuration files and they're just doing it as root because they're lazy. They didn't want to make it for all individual users because make it too hard. Simplifies the install. Don't blame them. It makes it easy. Okay. Now, what does this do actually? Well, let me show you what it does. I'll use it on my machine back here. Would help if I could type the name right. All right, there I am. Now, if I type in notes all by itself, it gives me all this wonderful help. Okay. And I can say new. There's a template option. Does all kinds of nice things. Find it, open it, append it, whatever you want to do. So in essence, this being a note-taking app, I want to say notes, new, and hit enter. And notice what happens. It puts it into tilde, home directory, me, in a notes folder with the name of ZJot. Why? Because my postman here is Z. My one in Turlock is A. So I know where the notes are coming from because I put them in the same file folder in Dropbox. And then it puts the date on there. And it's just using VI. And I say hello or whatever. Okay. I saved it. Got a new one. So I can say notes ls. Those are all of them. If I want to open one, I would say notes, open, and I'll go with 319. Yeah, isn't it cool? Very simple. There are some other changes. When you do this in your directory, it's going to put the suffix .md. Where's the config file? How do you change a config file? That's what you're going to go figure out. You'll learn how to use this. You could use this legitimately as a static website builder because it's using MD. You just document everything in Markdown and send it to your static website generator and magic. And it's just a bash script. So no excuse for not having GitHub pages. Okay. All right. Now, with the sshfs, there is a disadvantage of using that. Okay. How do I unmount it? Everything in test out is going to show you the umount command. Did you mess something up?
Well, it's like.
Oh, yeah, you're not supposed to be there. That's the system directory. So you mounted the system directory, not your local one. So you have to unmount it. So now you're going to have to say, how do I unmount this puppy? So where'd you mount it to? In this one. We went through this at blinding speed. And here. And just hit up arrow a couple times for me. So you get to an SSH. Or did you do SSH there? Well, that's a good question. So I wrote it down. There we go. That almost works, except there's one that, yeah, that should behave. Except we want, yeah, that should work. So did that work for you? Yeah, go ahead. Okay, now do df. So it's there. So type in cd space jmkll and do ls. That's all your stuff in your Jeremy account. Okay. Here, just type in cd. Now do pwd. Now do cd space bin. And then do ls. There you go. When you type in cd/bin, it's taking you into that system directory. Okay. Very common mistake. Don't feel bad. Don't worry if you blow up the box. I'll just have you help me fix it. Okay. That's just how it works. Okay. So to unmount this, one, I really shouldn't do this. I'm standing on the box and I want to unmount from the box, right? I need to get off the box first, right? That's what happens. I want to unmount this directory, but I'm in the directory. It's like chopping your knees off while you're standing on the box. Doesn't work real well. So you have to make sure you're not in the directory that you're trying to unmount. Okay. And how do we unmount this thing? Well, it's not rocket science, but it's using something that is specific to sshfs. Okay. We have something called fuse, which is the user area of mount file systems. So when you put in your pen drive, it's using fuse to connect to the pen drive to get to your data. Okay. Fuse is an entire subsystem ecosystem, and it goes on for weeks. So we have to tell it to use that to unmount. And the way it looks is we say F user spelled out mount and then directory. UZ. U means user and Z means now. In other words, sync it and then drop it. Now, before I run this command, I'm going to do something like this. So I'm going to change directory here, and then I'm immediately going to try to unmount it. Yeah, it worked. I stand corrected. I didn't expect that. Must have been a point change in they did a bug fix or something. Okay. Typically, you cannot unmount if I had a file open. Let's do it that way. Let's change directory. Now, if I do ls, do I have my Jeremy thing mounted? No. So let me go back in history here, 100 miles. There's a search command for this. Log in. Now, if I do an ls, whoops. There it is. I'll go into my bin directory here. Cat notes. There's my notes file. And I'm going to touch junk.txt, vi junk. I have a file that's open. There's the file I have open. There's my swap file. There's the directory I'm in. And I'm going to do that F user mount and see what happens again. See if it works with an open file. U means unmount. Z means sync it. Oops. It didn't unload it, but the file is still there. It doesn't show it as mounted. Now that I'm out of the directory. Boy, that could be trippy. I've got this big file open. All of a sudden, I unmount it. My big file's still open. That could be a problem. Like I said, sshfs doesn't necessarily scale, but boy, is it handy for moving data, provisioning machines. Like when I want to put a bunch of stuff on these machines, I use a combination of tools. That's one of them. Okay. All right. So everybody has their notes script in their bin directory on the Jeremy box. Okay, so let's log into Jeremy. Whoops. So log in as you. And in your bin directory, you should have notes. If you don't, let's get it there. Okay. Help each other, raise your hand. Warning, warning, we got problems, you know. So you want to copy it into your personal bin directory, not the system bin directory, because it will die.
I don't know what that is.
Oh, well, SSH, and then your login name. No problem.
Yes. When you do that, it's this.
That should work.
Yeah. Oh, yeah, so. Permission to use chmod.
Yeah, just hit up there.
Yeah.
Oh, you're in.
You're good, you got it. Plus,
All right, now CD space in.
Yeah.
CD space.
That's it.
Okay. Now, I can CP
If you want
a
to wait,
/home
-.
/logs /news space, or hit up arrow space dots into my current directory. Ta-da, there's your notes. Yes. Everything's easy when you know what you're doing. It's that first part of what do I don't know that I don't know that I need to know so I don't. So I feel like I don't know anything. Good, good. Good. All right. So on the 21st or sooner or later, play with this notes file, configure it the way you would like, experiment with it. And just for grins and giggles, let me show you. No. Oh well. Plan B. Here is a config file that it will use. Okay. And you can find where that config file lives in the source code. And what is interesting about this piece of code is that it goes through and it says, I'm looking for this file. If it doesn't exist, it creates it. So even though all we have is notes, we don't have the config file and we don't have the templates file. But once you fire it up, it will create those files for you, built into the script. So you don't have to create it ahead of time or anything else. You just run the script and it builds everything it needs as it needs it, which is kind of slick, which is the way bash scripts work in general anyway. Okay. Test for this file. If it's not here, make it. And then that's our new config file. Okay. All right. So on that note, go have some fun. And as soon as my cables from Monoprice come in, we will go through some wonderful machinations because we have to change the grub file. One typo, your machine won't boot. Restore from your previous backup. So if you mess up the box, we're going to get to have some recovery time, which will be fine. We can recover it. But let's see, where do let's see here. This is what I went through very quickly today. And I will make this, once we get the cables, we'll do this, okay? This is what we have to change in Grub. Okay. We have to actually change this. Now, if you're on a Raspberry Pi, there is no Grub. Uses a completely different boot sequence. So we're going to have to add these lines to the machines in front of us. Okay. And then to give us the ability to do the login, we need to do the next step. And then on our other machine, the one you'll, because you're creating a server, shall we say, and then from your neighbor's machine, you will connect the USB part of the cable to the 9-pin on the back of your machine. And then when this machine that has USB, you will be running this command. There are many options for these commands. We have, here's just a few. You don't have to remember them because I'll put all this up on the website once we do it. Okay. So that's where we're headed. And then logical volume manager. We will take our virtual machine and we'll add a drive and we'll add another drive and then we'll add another drive and then we'll connect the drives together and then we'll slice up the drives and then we'll mount the slices. Yay! And everybody goes, I don't want to do this. Well, no problem. Have fun anyway. Okay. This is the kind of stuff that, you know, I think it's fun. Therefore, you should think it's fun, right? I'll be pre-operational behavior here. It's the stuff that helps you get the good paying jobs when you can fix things. Like, for example, I had to shard a database on the production database at Foster Farms, and it was a database that did not allow hot backups. So physically, I'd turn the machine off at night, turn the company off, and I had to do something really primitive because it was the only option available. Now realize this was a database that was created before Linux epic date. It was created in 1967. So it's ancient. The database could only support 2 gig. Well, there's $1 billion company. So the keys in the file ended with digits 1 through 9. So I had to write a program that would take the last digit and shard the database, each one into its own disk slice, like you did with Logical Volume Manager, or will be doing. and I used Modulo to do this because it's fast. So I ran the update, sharded the database, and the machine stayed running. Because I told him, I said, if you don't let me do this, we are going to have some massive, painful downtime because everything in the database will be corrupted. There will be no data available. And they're going, oh, yeah, we could put it off. Fire me now then. And he said, what? Yeah, fire me now. And that got his attention. This is the guy that couldn't even use Word. He had no idea what the technology was about. So it was, so once we did this, it was a long weekend. I sweat a lot of bullets, but it worked just like as advertised. There was not any major performance increase, but there was also no performance decrease, which is what I was more concerned of, because this does tend to slow things down. But that was the pain point when management said, maybe we should get off this thing that was from the 60s and come up into the 2000s. Yeah, you think? So now they're owned by yet another company. So who knows what they're running? I can only imagine all the IT people are screaming right now. Fire away.
Well, did you like punch cards and vacuum tubes?
Pardon?
Did you like punch cards and vacuum tubes?
No, it wasn't quite that old. The PIC system that this was actually developed from used a very novel idea that every single one of you are using today that you don't even know it. Perl, Python, Bash, Lisp, Guile, Lua, they all, when they instantiate, create their own virtual machine. That's what this system did back in the 60s. It was all a virtual machine, but it was very much limited by the way they designed it because they had very limited hardware in those days. So as the hardware expanded, they didn't upgrade the technology. So it's basically the PIC programmers now can't even make 15 bucks an hour. There's no work out there. But at one time, they're making 350 bucks an hour in the 80s. Same thing with COBOL. You could make a bunch of money in COBOL in the 60s and 70s. Now, it all goes to India. So where's your language going to be in 10 years? Think about that. That's why you want to learn the new stuff. It may not stick. C still works. That's always my go-to language. C, not C++, C. Because I know it's still going to work. And it's still rated top 1 and 2, and it has been since 1988. But there's no big new development in C unless you're working for NASA or Tesla, or you're doing something very, very, very focused with hardware. Okay. Imagine being the person that designs the chips for a self-driving car. You have to get it right. And then when you work for the company that gets it right, they're not going to give you a dime in royalty. But if you don't do it right, you think you'll be the one that's sued? I don't know. Depends on the company. Anyway, have a fun weekend and enjoy the notes program. You'll have fun with it. More notes will be coming.